So in the morning we touched about sustainability, right? So we talked about sustainability, we talked about how we are going forward, what is ABB part in display, how can we work together, how can we collaborate to support you in your journey. And our part in display here, me and Clemens, what we can help you with is really these boxes that you see on the right hand side. How to better manage the energy consumption in your plant. And I'm not only talking about electricity, but all sources of energy. How can we help you optimize that? So both from the power generation side, but also from the power consumption side and the energy consumption side. And how can we make that more efficiently? How can we work on your emission monitoring and reduction? So how can we help you deliver that? And what are the tools, what are the systems that we can provide and work together to achieve that? And last but not least, also focusing on the process safety. How can we make that in a way that your operations is as safe as possible? So that is the least but the most important one. So some of the things that we have in OPTIMAX product will be helping you to, for example, some of the cases reducing the energy consumption by 2 to 5% annually. So that can be massive depending on your operation, depending on your plant. So cutting emissions in a scale manner, and also some other return of investments. So if we go to the next one, we have wrong order for the slides. So where have we done that? We have done that around the globe already. So more than 200 installations, 5 continents, 29 countries. We have been deploying OPTIMAX since, I don't know, more than 10 years at least, right?
I would say 20 years with
20 years.
optimization.
All right. So this product actually started on the power and water side, and now we're, or not now, but a few years ago, we are also taking it into the industrial side and taking it into the refinery and chemical plants and so on and so forth. So if you move to the next one, please, Clemens. So we brought 3 project references here for you. Maybe they are not connected with the blending process, but they try to highlight the functionalities that we have in OPTIMAX, the 3 different modules that we have in OPTIMAX. First one, Krieger's Flak, that is the power grid connecting Denmark and Germany. Here we are actually talking about a high voltage power link between these 2 countries, where we provided a solution to optimize the energy flow between Denmark and Germany. So here really talking about energy optimization, which transferring methods we could be applying on the electrical side. Second case, Wintershall, did I pronounce it correctly? Wintershall DEA in Germany, that's the biggest oil platform in Germany, where we are playing then the energy monitoring and reporting part. So we are not only looking into energy, electricity as I mentioned, but also the gas and the fuels. So helping them to monitor that and to have a clear control of what they're doing there with a reporting package, extremely practical. So that was one of their problems, how to create something out of the data. We were talking in the morning about acquiring the data and getting the data, but how do you transform that into information so you can actually take cleverer decisions? So this is one part of the OPTIMAX as well. And last but not least, our example on the hydrogen production facility that we have here in France, actually, with the F Dynamics. So where we are optimizing the entire process for hydrogen production and storage. So again, talking about optimization. So as you saw, we have these modules in OPTIMAX that Clemens will be covering better in the next session.
Yes.
Oh, yes, the last one. This is also about the monitoring and reporting. Maybe you can talk a little bit about this case. I think you were involved in it, right?
I was partly involved, so I'm not the expert in this project, but yes, it's a special chemical plant in Rheinfelden in Germany, and we did the same approach like with Wintershall there. We applied energy monitoring and reporting to this plant. And the problem is that our customers in this area, they need to report on a yearly basis energy audits and emission audits to our German officials, but also, of course, in other European countries probably you will have the same challenge there. And we actually helped our customers. I mean, the Wintershall project is running since 2021, since 2 years, to successfully pass the audits. Of course, they passed it before too, but with this solution, they could pass the audit even faster and even more efficient. This is what we got as feedback.
Yeah, that was an interesting case. If you just go back, because there was a sentence.
Are they allowed to ask the specific questions while you're presenting?
Yes,
or
please.
That specific application, when you monitor the emission, maybe the carbon footprint,
Yeah.
and you reported it against a KPI by certain corporate. We have some customers here who are really interested to do that because maybe they have been watching this and either missing the KPI or not being able to see it coming, that they are going to miss it at the end of the year. So is there some elaboration or example? What screens did you see there? How do you see it coming?
Right.
That you're missing your KPI?
Thanks for the rehearsed question, Yasser. That was perfect.
Customer feedback. Not
Yeah,
me.
but that's great. This was actually a very interesting case. As you see here in the screen, the customer actually had the historian system. They had the data available, but they had to do everything on the side on an Excel format, anyways, manually. So that was where we came into play with OPTIMAX and helped them to see valuable information out of the data they had. Clemens will have the demo for the carbon index monitoring part,
Okay.
where we are showing how to be compliant with the ISO 50001 standards. And then hopefully more questions will arise, so you can point to the customers and help them excite their questions. Yeah.
Yeah, can I ask you something?
Yeah.
So the KPIs, that's on a pretty high level. But when it comes to the identification of the tactics to be applied to make the energy savings real, is this also your team running then this kind of probably workshops to identify tactics?
That is,
The answer is yes.
yeah, that's,
Yes, we get the electrification. Depends on which area you're looking at. If you're looking at the rotating asset side or the electrification side, we have teams from both that work alongside with us. So once we get parameters set, get objectives clearly understood from the customer, we'll then get one of those teams involved, either electrification or the motion teams, and they'll come alongside with us and help us work with the customer. Now, okay, how do you meet your future KPIs that you need to meet in order to be compliant with company policy? So we can.
So
Yeah.
it's not, let's say, only about setting up the software tools to create the
Yes.
overview, but it's also about the implementation of measures to make really savings visible or happen.
Yeah, we work alongside with your sustainability team, and as they look at developing the strategy execution, what applications that you're going to tackle, and how you're going to tackle those application stacks with what different technologies. We can work alongside with those teams, and very often we're doing that on a regular basis. So happy to do so.
Thanks.
But yeah, because usually we get the phone call right after the new mandates are set and new targets are set. We'll get the phone call around, we need help. Help us figure out how we're going to get there. And that's when these teams get involved.
thanks, Gino.
No problem.
All right, so now Clemens will take us through a little bit more on the technology side.
Thanks.
Do you want me to move the slides, or are you fine with this?
It's fun.
Yeah.
So you might ask yourself, I mean, a couple of various diverse projects, what is the common basis for our solution? And actually we have three main features we are highlighting all the time. The first feature is the monitoring and reporting, like discussed with the Wintershall project, where we actually, first of all, need the data, that's for sure. And we as ABB, we are pushing for OPC-UA, open standards. And I can just, let's say, engage you to also use open standards in data acquisition. It's very important. The second main feature, and this is more or less related to the Krieger's Flood project, Leandro was talking about, sorry. Here we are normally having physical models, physical process models, but also data-driven models, depends. And those models are feed with forecast data. So for example, wind power forecast in the Krieger's Flood case. And then the physical model is calculating optimal schedules for different plants. The third point is the so-called real-time optimization. This is what we are doing in virtual power plants, for example, scheduling a pool of generating assets, or with the Auxerre case, the hydrogen case, meaning distributing an overall set point to underlying assets. In the electrolyzer reference, you could have modules, or you could have even two electrolyzers, and probably you need to distribute those based on efficiency curves, for example. And then question would be how we can, especially for optimization use cases, how we can serve such different process models. And actually we are experts in process modeling, I would say, our team. And we're using Modelica for modeling multi-domain models. Like you can see here, we started with the electrical domain and the steam domain, like I told before, power plant optimization, but then, of course, also this virtual power plant aspect became important with the decentralization of generating units, like PV or wind. Then, in recent years, and also this is highlighting to the cool collaboration or electrifying heavy industries, power to heat is something we are capable of, but of course also power to gas, especially hydrogen. And we think that only with a holistic modeling approach you can really leverage efficiencies in the end, because it's a highly complex process normally, and different kind of energy types are playing together.
So are those items that you're listed under each of the sections is what you accomplish out of the model? Means using that model you are able to address what the heat pumps are and optimize how the waste are coming out of it? Is that basically what you're saying in this model?
So
just an example of the thermal piece.
Internally libraries for different domains. So electrical libraries, heat libraries, gas libraries, and steam libraries. And those components within the libraries are then used for projects. Of course, this can be, it may be better than me, can be different than real execution. Then you need to model another component or whatever. But that's actually our library.
Okay.
So yeah, these are the standard libraries. When we come in and execute a project, we're not going to build it from scratch. We're going to build from a set of libraries that we already have. So when we step in, we'll take our standard library, we'll tweak it to what your factory, what your situation looks like, and then we're off to the races. So what that means for you, faster time to deployment, faster value.
And optimized models as well.
Yeah.
Exactly, and that
Yeah.
is based on the learnings from the team, from other projects and so on. So that's why.
And besides the modeling, there's another aspect which we are thinking is important to serve different kind of business use cases. It's the deployment. And we believe that, of course, cloud is at the moment very important, no question regarding this, and being agnostic to different cloud providers. Microsoft is our, I would say, preferred provider, but it can be deployed also in Google Cloud or AWS. Not only internally in the ABB framework, but also in the customer framework. Then a second aspect is virtual deployment, so virtual servers on site, especially for critical infrastructure. This is still of importance if you are optimizing and controlling assets. Then cybersecurity requirements, of course, are even higher than normal. And the third use case is the bare metal installation. And all of those three deployment options we are offering. So it depends on your needs there. Okay. And actually I'm showing one on-premise deployment and one cloud deployment. So I have two demo systems to show. So this is the first one deployed on-premise on a virtual server. And like Leandro mentioned already, this is our carbon and energy management suite. And typical dashboard you can see here is, first of all, showing the data from the plant and contextualizing the data, meaning classifying assets. And and not only assets, but also energy types in this case, but this could be also adapted to chemical products or whatever. So classifying and bundling different asset types. And then in this case you can see the energy flows of the electrical side and of the gas side. It's a typical refinery plant as an example. And such a refinery plant normally has some kind of power generation. And then the power generation and maybe gas or maybe steam is distributed to underlying components. And this is what we are showing here. The user's capable of browsing quickly throughout the plant and see all of the different energy types and flows.
So, if you think about your facility, this is the type of view you would be able to see. You'd be able to see your pump power consumption. You'd be able to see your total consumption. You'd be able to see what the building is consuming. So from one central place, you'll be able to see what your energy footprint looks like on the fly, if you will. So that's really where when customers are trying to get a border around, what is our total power consumption? What are our power drivers within our enterprise? This is where they get that view from this tool.
And that actually gets us the basis for what your question was, Matthias. So this so to say ground field of information that breaks down where the energy is being used, how it's being consumed, who are the main villains, if you will, in terms. That would be the base ground for then allowing us to take the next step, which is the optimization part, and then delivering those savings automatically.
Besides this real-time information about the topology of the plant, also the possibility to show KPIs, real-time KPIs. This can be highly individual and can be also really fast developed.
Can you put a specific equipment KPI factor that when this specific sector of equipment shifts from that KPI, either historically or trending to, can it alert you? Can it show you instead of blue, red, or something like that?
Sure. I mean, we have normally events and event lists,
Mm-hmm.
but on the other hand, ABB has, of course, also solutions for real alarm management in the end.
Okay.
Digital solutions, and this is what we can offer. We can offer simple alarm management, and we can say, okay, we're combining our solutions together and then having a more complex alarm management in case.
Yeah, it's more of a KPI alarm,
Yeah.
not just normal alarm.
So if you have a pump that's consuming more power than is regular, you can do anomaly detection on that asset and automatically be flagged that, hey, we've got a pump, there's something wrong with it, it's consuming way too much power. And so you can flag things like that in the system, yes.
Simple alarm management also includes sending emails or notification messages to the user in the end. So, but I would say the real alarm management is a bit decoupled from that.